Hello? Hello, hello?
Hello, miss.
Oh my God, hindi ba kaya itong pagkuan ni De La Cruz for a while. I don't know. Tingala sa go. Very unstable. Sige, magkita rin lagi tatanan. Sorry. Okay. Can you see my screen? Let's go back here.
Yes, ma'am.
Okay, right. Okay. So please just come in, no? So I don't know if it's I think wala ko labot ani kani yung Google Meet or ang Wi-Fi. Okay. So going back, no, I'll just for a while. Polarity, no, you talk about charges. Very good. Because dili lang ingon nga sa mga kuan lang ang polarity. So it also talks about charges as being positive and the negative ends of your charges. Can you continue? De La Cruz or nanood na ka?
Hello, miss.
Wala na.
Hello, miss.
Sige.
Ay, ako na lang balik,
Yes.
miss. Sure.
Okay, okay. Sige, go.
Polarity has a huge effect on how attracted a chemical is to other substances. Some molecules have a positively charged side and a negatively charged side. For example, the positive side is attracted to the negative side of another molecule. So the larger the charge difference, the more polar a molecule is. You find that as you increase the polarity of the solvent, and all the components of the mixture move faster during your chromatography experiment.
Okay, okay. Moves faster. Thank you. Anything you would like to add, Ryan Sunggayan?
Example of polar solutes or non-polar are saturated hydrocarbons, olefinic hydrocarbons, and aromatic hydrocarbons. With those have weak intermediate polarity, the examples are ether, ketones, and aldehydes. Alcohol, carboxylic acid, and phenols have strong intermediate polarity. And lastly, polyhydroalcohols, amino alcohols, and hydroacid are strongly polar.
Okay. Thank you. How about Enoch? Is there anything you would like to add for polarity?
So, how does polarity affect GC separation? Well, if the polarity of the stationary phase and compound are similar, for example, both of them are polar, the retention time increases because the compound interacts stronger with the stationary phase. As a result, polar compounds have long retention times on polar stationary phases and shorter retention times on nonpolar columns using the same temperature.
Very good. Very good for using polar and polar, no, the same polarity. So very good. Okay, so as we've mentioned also earlier, no, we now know the power of polarity, and it's not only dependent, it's not only true to your gas chromatography nga na ay effect ang polarity. So it's true to all the separation techniques for your chromatographic theories or your chromatography. So polarity is definitely the driving force of the separation. So if polarity kay pareha or sa name dili sakto dili siya mao ang ginagamit, so that means the any operation, any chromatographic separation will not succeed. Okay, or dugay, so katong mga taas ang retention time or mubo ang retention time. Okay, so thank you for that one, Ortizano, Songayan, De La Cruz, and Ino. So from what I've heard, no, from the previous groups, I'm glad that everyone had the opportunity to talk, no? So I assume that you really prepared this one and sani, you divided the task. So dili tayo na nag-istorya aning inyo yung gibahin. That's a wala moy, wala ra mo na separate. Pareha ra mo polarity tanan. Very good. Thank you. We're done with volatility and this one. Okay, let's go to kanisira. Naan sila kung ano mga clarification, but they can do it. Lucero, Largo, Lipitan, and Manhattan. So they're asked to explain, no, adsorption chromatography, because in adsorption chromatography, i-explain dyo dito ang relationship sa mobile phase and absorption sites. Okay. So, before we go to the theories, can you tell us about absorption chromatography? Largo? Unsa di ay ang absorption chromatography? Is Largo here? Lucero? Hello?
Excuse
Hello?
me.
Nihinay ko luhat di ko.
Ha?
Murag hinay ang signal ni Krista po kay nagputol-putol daw ko sa iya.
Ni Largo?
Yes po.
Oh, yeah. Na-late bitaw to siya. Sige. Maybe I can have Lucero. Is Lucero fine?
Good morning, Miss.
Yes, yeah. Let's talk about absorption chromatography first. What is absorption chromatography?
So first, let us all define what is absorption chromatography. So, absorption chromatography is the oldest type of chromatography technique. It makes use of a mobile phase which is either in a liquid or gaseous form. So, when a liquid is used as a mobile phase, it is called LSC or liquid solid chromatography. And when a gas is used as a mobile phase, it is called the GSC or gas solid chromatography.
Very good. Okay, so it has other names, no? And it has many types as well. Just like your gas chromatography nga na siya, GSC, na po siya, GLC. Okay. Okay, maybe we can proceed to the relationship of your mobile phase and absorption sites. Okay, so your absorption sites is your stationary phase, no, for this one, and of course, your mobile phase. Okay. Maybe we can have Manatad for the explanation for the relationship of your mobile phase and stationary sites.
Okay, Miss. So, good morning everyone again. And sa SAS, based on the SAS, kay if the interaction between the mobile phase and adsorbent sites are strong, only a small amount of analyte will be adsorbed at any time, and the movement of the analyte through an absorption column will be relatively rapid and closely follow the solvent front. So, meaning, if strong daw ang relationship between the mobile phase and ni stationary phase or adsorption sites, ang imuha daw ang analyte or ang ang mobile phase daw ang katong nag-move through the column kay mas pas-pas ang ihang move o mo closely follow the solvent front. But if when the interactions between the mobile phase and absorbent are weak, greater amounts of analyte will be adsorbed at a time and the movement of the analyte through the column will be slow. So if weak gani ang mobile phase and adsorbent ang ilang interaction, meaning mas dako kuno og amount sa analyte ang ma-adsorb or mo-adhere sa surface sa stationary phase, and the movement daw sa analyte sa sud sa column kay slow daw.
Okay, thank you. So, pareho na siya, no, kay rapid man. So, meaning, gamay lang yung ma-absorb kay paspas man na yung dagan. So, if taas, if hina yung dagan, so meaning, daghan kayo siyang time to adhere dito sa surface. How about lipitan? Would you like to add for this principle of your absorption chromatography? Is lipitan here? Is
I think
yeah.
Miss wala siya.
Silipitin? Okay. So only okay. So this group, no, Lipitan and Manatad, asked some clarification regarding absorption chromatography because when they tried to search it, it was quite confusing or different. So I was able to resolve a question from Lipitan, no, because if you search it sa mga kuan man gud, engines, mga Google or anything else, depending on the reference, no, the terms or the terminologies really becomes different. So, but the idea of the separation is there. So, kana lang murag gi-clarify lang nila nga kung sakto ba ilang nasabtan and sakto ba pud ang ila ang nakuha sa internet. So, there was no problem. So, maybe nag-differ lang sa mga terms nga present um, adto nga reference. However, another insight from Manata that ang nga po siya nakitang laing reference nga ingani po ang explanation regarding the strong and weak attraction. So, I'll have to check that one and I'll get back to you, no? Maybe I could just chat that one and inform you sa atuang group chat. So, I really commend, no? Thank you for clarifying and verifying some information as well. So, in the future, if I am your teacher or I am not your teacher, no, do not hesitate to ask your teacher. Balag dili mo reply si ma'am or si sir, just ask. So, kaya para maka-think po ba nga, maybe the other references, no, or maybe nanay changes ni advanced na baya ang science. So, maybe there are realizations or mga difference na nga nahitabo sa world. So, I'm really open for that one. So, thank you for that. So, sige. So, nawala si Lipiting?
Yes,
Miss,
Miss
anak ko,
Winnie.
miss.
Wala na din siya. Sige. Kay nagkuhan namin, nagchika-chika. Sige, is there anything you would like to add for the mobile phase and absorption sites?
Miss, the allotropic series, miss, which is a series of solvents with an increasing degree of polarity, is generally used to explain solvent strength in liquid solid or adsorption chromatography. So the selection of the appropriate upper phase liquid requires a polarity scale known as the allotropic scale, which will be ranked according to the order of strength of adsorption, miss.
Yes, very good. So, what you were trying to say is that the strength or the weakness and the rapid and the slow motion of the samples is still dependent on the polarity, no? And we could actually check for polarity, no? If sa ang strength, if suitable ba siya for the mobile phase for your adsorption chromatography. So, if you look at your module, you have that one in here. So, see absorption chromatography. Their interaction is strong and weak kay nasa diri sa inyong module. And this group tried to simplify it for you. So, naay gitawag na slow movement and naay gitawag na fast movement depending on the attraction present. Okay? That's it for absorption chromatography. Thank you, Lipitan, Manatad, and Lucero, and Largo. It's okay. Thank you. And finally, we are now in spectral versus chromatography. So, why I included such question na anong spectro versus chromatography? Because if you will try to mag-think mo karon yesterday nga, what you knew about spectrometry is somehow ato po siyang i-try o connect sa chromatography mo. So, let's hear from Mancha, Ranyola, Rivera, and Suluba. So this is the last question for Module 9. And this is for Module 10. Can I have maybe Rivera to give us a quick review on spectrometry? And so the IC spectrometry again.
Hello everyone. So, a little throwback sa atong SAS. SAS 7 and 8. Spectrometry is a method of analysis involving the measurements of spectrum, power transmitted, fluorescent, reflected, or emitted energy. So it aims to identify separated components in a mixture and the interaction of analyte and electromagnetic radiation.
How about chromatography?
What we recently learned, it is a process of separating inert materials, drug particles, and impurities from a mixture. So what it does is actually just separates components in a mixture.
Very good, no? very good for mentioning impurities also because your chromatography really deals with impurities as well, no? Because hindi siya impurities sa atong mga hugaw, mga ana. But also identifying ba, for example, you have, what's a very good component? Maybe you have calcium. You just wanted to separate calcium from the rest. So the rest, which is magnesium, which is carbon, these are the impurities. So the impurities tells you nga, dili itong mga hugaw, but the ones that the unnecessary, dili siya mo imong target. But you targeted your calcium. Okay. So again, spectrometries, we had this one yesterday, talks about spectrum, energy, radiation, and absorbance. Your chromatography is very simple. Separation of your components. Anything else? How about Ranyola?
So again, to explain it or like to simplify
Mm-hmm.
it, spectrometry is to identify and chromatography naman is to separate. But what we don't know is that chromatography and spectrometry can be paired together. So we have this thing called the gas gas chromatography and mass spectrometry. So it is the gold standard in drug testing. So what it does is it separates the it separates the compounds at first, and then the mass spectrometry is used to analyze those fragments or compounds that is specifically used in drug testing.
Very good.
That's just
So,
one of the applications of it po.
yes, okay, very good, no? So, actually, mato ako siyang iingon. But thank you for telling the class for that one. So, very good. You can identify and separate for spectro and chromatography. However, very good. You can actually use them together. So, that's the importance that I asked you to compare spectro and chromatography. Because if you remembered, you have your spectro, diba? And you have also your detectors. So the detectors, after that, you have your readout. And if dili pa gusto pa jud kamo, if you go back to the first slide, no, if you want to analyze, to purify, to characterize, you can have you can attach your chromatography and spectro. So they can really be used in combination for further analysis. No, so that's very good. So there is separation and there is identification, and because the two can be used together, so gamitin sila. So if you remember your mass spectroscopy, so sa mass spectroscopy, sure ka nga na adjud ni siya ing ani nga sample. But you wanted to make sure na kanir gud siya nga sample. So you wanted to separate the other components using your gas chromatography or the other chromatographic separation techniques. Okay? Is that clear? Follow pa?
Yes po.
Okay. How
Okay.
about Mansha? Is there anything else you would like to share for spectro and chromatography?
Yes, Miss. Aside from the, as mentioned by Miss Ranyola, aside from gas chromatography and the combination of gas chromatography and mass spectrometry,
Mm-hmm.
there is still another combination of both. So we have high performance liquid chromatography, the HPLC, and the mass spectrometry. So a fun fact about that combination was during 2013 there was a horse meat scandal. It is when the meat of horses entered the supply chain as beef. So, imbis na horse, kaya it was labeled as beef. And ended up being sold in many products in the UK and nikatag siya sa England. And this scandal infiltrated numerous supply chains and lead to millions of product being withdrawn from the market. So in line with that, they concluded nga ang traditional method of determination of raw samples kay ineffective because of that scandal. So they used HPLC-MS combination to successfully find out if the meat that had been labeled as beef was beef. If it was labeled as horse, then it was horse or a mix of these and some other various ingredients. That's all, miss.
Thank you. Is my screen still here?
Yes po.
Ara? Okay, thank you. I haven't do not disturb. Okay, thank you. So that is news, no, for the use of your spectral and your chromatography. So it goes back to our first few topics nga katong mga recall and withdraw, or definitely just talking about quality. So dili lang siya about drugs, dili lang siya about impurities or chemicals. It's definitely also applied in food. So na-realize nila nga mas powerful di ay if we use this kind of method. So very good. Thank you for that news, no, for that information. How about Suliva? You would like to add?
Yes po, Miss. I would like to add to what Miss Mansha is tackling about high performance liquid chromatography with combined with mass spectrometry is that both are extremely versatile instrumental technique whose roots lie in the application of more traditional liquid chromatography to theories and instrumentation that were originally developed for gas chromatography. So as the name suggests, the instrumentation compromises an HPLC attached with a suitable interface to a mass spectrometer.
Very good.
And I would also like to add that HPLC can be combined with with further its capabilities, making it an ideal analytical technique for pharma to ensure the high quality of drugs. So, so the two most common interfaces used for HPLC and MS are electrospray ionization and atmospheric pressure chemical ionization interfaces.
Thank you. Very good. So maybe no in the future or basta makabasa mo when you read the news, so makakita mo mga HPLC attached, no? Sakto siya nga term attached with mass spectroscopy. So mo dyan is lang common because as mentioned yesterday, mass spectroscopy is one of the most powerful spectrophotometer, no? So gamiton good siya. So siya usually ang ginagamit. And ako kayo siya nga machine dyan. So kakita mo mga nga na, so meaning makapansin mo nga, this is for separation and for identification. So, naman mga daghang kayong thesis, no, study nga, gina-compare nila ang chromatography and spectroscopy or gina-combine nila for their analysis to get the analysis of water, analysis of drugs, maya na siya. So, that's why for the module 9, 7 and 8, and then 9, spectral and chromatography, dili good sila malahi. So they are actually can be used together and becomes powerful together. So from from separation and then to identification. So pwede na sad nga mamili ra kag isa. Depende sa imo ang focus sa imo ang study. Kung gusto ka nga silang duha imong gamiton. Okay? Thank you for your inputs. Mansha, Ranyola, Rivera, and Soliva. Very good. So before that, I'd like to. So we have the terms like quantity, quality, quantification, and quality. Sorry, it should be quantity, qualification. Quantity and just quality. Okay. So looking at it, quantity, it talks about, it refers to numerical values. And quality is simply knowing or identification. So let me ask you, is spectrometry quantity or quality? Or you could also, pwede pa siya both? Which one do you think? Pwede siya both, but which one do you think it could be? So this is not just a question for the group, no? Anyone from the class could answer.
Quantity, Miss.
Quantity for spectro. How about the others? How about chromatography?
Mao siya quality, Miss. Kay like impurities man and katukuan. So
Okay, so that's correct, no? So if kakuan mo nga, pero murag both man jud sila, miss. Yes, it's also correct because it will quantify or and also qualify, it also will identify, no? Or it will identify and it will also quantify. So for spectro, you know that it's quantity because it will give you directly the absorption, and the absorption will give you the concentration of the components present. For chromatography, you are only separating. That means, nakabalo lang ka nga na ay tulo, upat, pulo ka components. And that's it. But if you proceed to further analysis, pwede na ka mag-discover sa ang quantity. But if you will say, Miss, naamagay pa siya numerical values, ang RF value. However, it only tells you that it's polar and non-polar. It will not tell you nga, kuan siya, 5% lang siya ani nga concentration. Diba? Nag-gets ra?
Gets ra,
Yes,
Miss.
Okay,
Miss.
very good. Mabright ka kayo.
Yes.
Perfect, managwan ninyo ang exam. So, yan, maybe very simple question lang sa exam. Which do you think, which of the following best describes spectrometry? Pareha lagi ni sila tanan, miss, no? So, mga ana. So, again, your spectro will definitely give you numerical values like your concentration and your absorption. For chromatography, it is simply separating and identification lang. Like, okay, naani siya, naani siya magnesium, naani siya calcium, but I don't know how much. So, kailangan sa ako mo gamit og laing machine so that I will know kung pila siya. Okay? Okay. Thank you. Okay, so wala niyo siya sa inyong module, but this is like a summary, no, of how we've learned your GC, HPLC, and your PLC. So let's try types of chromatography. Let's say, for example, gas chromatography. So other names you have, no, pwede ka o katong GLC, pwede po ka o GSC. So if we use a GLC lanta for this one. What's your mobile phase? Is it liquid or solid? I'm sorry, is it gas, liquid, solid? Mobile phase.
Liquid.
Liquid.
For your mobile phase?
Gas.
Gas.
Ay, gas po. Gas po.
Layla.
And your stationary phase?
Liquid.
Liquid. Solid.
So, mana ni siya giingon, no, nga liquid or solid. Pag-abot sa exam, dili ba siya naka-table? So, maybe I will just directly ask, which one is the mobile phase for GLC? Liquid man na ito. Okay. So, kaya ano siya. So, perfect ninyo exam. Let's have PLC. Other names, maybe, let's say none. How about mobile phase for TLC? What's your mobile phase for thin layer chromatography? Okay, that's liquid. Definitely your stationary phase is solid. What else do we have? HPLC. Other names? So if you also read on other references, it could also be high performance liquid chromatography or high pressure liquid chromatography. So the P could be a pressure or performance, depending on the brand. I don't know. Mobile phase for HPLC.
Liquid po.
Still liquid. And your stationary phase is solid. So sometimes, some references would not say solid, but they will actually use silica or other examples. But it's solid. Okay? But for me, for the exam, of course, your option is only gas, liquid, and solid. Okay. So basi malibog mo ha for your liquid chromatography. Ang sa GC, your GLC, and your GSC. Okay. Very easy. I also have a cat, so sabi lang na sila. So for your module 10, you have the miscellaneous method of analyzing pharmaceuticals. Why miscellaneous? Because they can be used and they can also not be used, no? So it's miscellaneous because murag part lang siya sa mga imuang preparation for your sampling, or part lang yun siya sa imuang procedure, but it was not the highlight of your method, of your identification. Dili pareha ni spectron, ni chromatography nga siya jud imong focus, diba? So maybe before ka nag-spectro, nag-pH ka, or after ka nag-spectro, nag-pH ka. So that's miscellaneous. Okay? So part lang yun siya nga ginagmay. So for module 10, I'd like to focus for pH and viscometers. So your amperometer, your voltammetry, and potentiometry, this is just by definition, no? Just have to find out unsaya ang mga roles, unsaya ang definition. Because I'm not really wala kayo ko'y nakuanan na gagamit kaayo siya sa pharmaceutical. But there are times, there are instances na gamiton siya. That's why it's called miscellaneous. But pH and viscometers are very important for pharmaceutical products. So let's go to that. Can I have Donal for what is a reference standard? Why do we have a reference standard?
Good morning, Miss. According to USP, a reference standard is a highly characterized specimen of drug substances, excipients, reportable impurities, degradation products, compendial reagents, and performance calibrator. It can also be defined as highly purified sample of a particular compound that has been characterized so that an accurate content can be stated. And reference standards are not intended to use as drugs. They are intended for test and assay use only.
Very good. Test and assay. Very good. Anything else? It's a very short topic, but let's try to flex it. Assis, anything you would like to add for reference standard?
Reference standard test evaluation for both process and product performance and are the benchmark for the assessment of drug potency for the patient consumption. It is also used to determine qualitative data such as assay and impurity, qualitative data such as identification test, and calibration such as melting point standards. Therefore, the quality and purity of the reference standards are crucial to achieve scientifically valid results.
Very good. Very good. How about Beltran? Maybe you can give, do you have examples for reference standard or anything you would like to share? Anything else you would add, Beltran?
So I'll add the importance about reference standard is. The importance of reference standard is to promote improvement of pharmaceutical products, ensure the maintaining of high quality products within the across countries, serve as quick reference for drugs, medicinal drugs product, raw materials, and manufacturing procedure.
Okay. Very good. How about Salcedo? Is not here, no?
Wala, miss.
Wala, miss.
Is not able to participate as well. So it's only the three of you. Okay, so very easy, no? Reference standard. So napakay word na standard, napajugay reference. So that means not all tab gigamit nga standard, mao gyud siya ang inyo ang i-reference. So when you create something, you have to have a reference standard. Even using your SOPs, if you use your SOPs, no, you have to have your reference standard. If example, maghimo mo og tambal, so you have to have your reference standard. So good terms, no, it is a highly characterized compound. It's highly purified because it's a reference standard. It should be perfect. So kamo, reference na mo, reference standard na mo, you're perfect na, no? Yan na dapat ang inyo ang material. So it is definitely very good for highlighting. It is not used no for it is not used as a drug, hindi siya gamiton for the market, but it is only used for test and assay because it's a reference standard. And most importantly, when you read articles or notes, you will really meet the word benchmark. So when you say benchmark, it is the siya ang gibasihan. So siya jud kung malabwan nimo ang benchmark, then okay. Kung di mo malabwan ang benchmark, you have to improve. So the reference standard allows for improvement. So let's say for example, when you did your last four, no, when you use your C2 and you had your trial 1 and trial 2. You did your trial 1 and trial 2 because you'd like to verify the truth about the C2. And let's assume that your C2 was your reference standard. And when you use your C2, you had at least 210 ml, no, as labeled volume. However, when you check it, when you performed, you arrive at 230 ml. So it's definitely far from your reference standard. Okay? So that means si C2 nga imo ang label nga volume mo siyang imo ang gibasihan, di ba? Na okay, kailangan maka-achieve ko ani so that ma-refer ko nga perfect ang ako ang kanang trials. Okay? But then again, the ones that we have in the market is not the reference standard, but it passed, no? Nakapasa siya to be the product para available siya nga product sa market. Because again, the reference standard is not found or available in the market. So siya lang jud, na siya sa lab, sitting in the lab, waiting nga for comparison. So dito sa sulod sa paghimo sa C2 or your biogesic, no, kana sila. So it really have the reference standard. Ang imong reference standard daghang giagian, calibrated instruments, tanan jud, tanan siya jud ang imong model. Okay. So I'm sure it's already very clear what's your reference standard. Okay, Ra? Follow, Ra? Very easy.
Absorbing, miss.
Sige, basta ang reference standard, siya jud imo ang basis, no? So it's very correct when they said it is highly purified. So meaning, wala gyud siya impurity, sakto jud yung pagkahimo tanan. And the rest of the products could also be perfect, no? Because if na-achieve nila ang pagka-perfect sa reference standard, then all the products are perfect. No? So, however, si reference standard, bilin lang yun siya sa laboratory. Kaya siya man na imo ang basis. Okay? Sige. Mura na po na og sa inyo ang module ba, inyo ang answer key. Mo ito inyo ang gibasihan niya. Sakto kanya kung answer when you try to solve it, ay sakto ready ay. So meaning, nag-compare ka from your reference, no? From your answer key. So, however, ang imo ang reference, dito rin siya. But imong isubmit ang imo ang answer. Even if mo ni siyang imong result. Okay? So, reference, na lang. But it's now a powerful one. Reference standard. So, mo ni siyang gigamit sa tanan inside the laboratories. Okay? So, katulad, nakabalo na mo nga na amoy SOP, na amoy raw materials, packaging materials, and gusto di ay may gigamit sa inyo ang QC, di ba? Para makabalo sila nga quality ang ilang product. They have a reference standard. So, na-adjud ka, basihan. Sige. Ikuan sa na siya i-digest. Thank you. Very quickly, let's go to pH. Let's have 5 minutes. Okay. Brizo, what is pH di ay?
Ay, wait lang, Miss. Narami send sa GC.
Naman din ko an intermission. Gigi.
Wala, notes na, Miss.
Okay. Thank you. Sige. So, let's start. Yeah, I see it already. Brizo.
Good day, everyone.
Mm-hmm.
We are here to present to you a little insight towards the importance of measuring pH in pharmaceutical products. So before we go on, we have to define first what is pH. So in layman's definition, it is simply the measurement of the acidity or alkalinity of a fluid, in this case, our pharmaceutical product. The pH of any fluid is the measure of its hydrogen ion concentration relative to that of a given standard solution. The pH may range from 0 to 14, where 0 is most acid, 14 most basic, and 7 is neutral. pH stands for potential of hydrogen or power of hydrogen.
Very good. Power or potential. I'm sure you know that already. Anything else? Aro. Aro? Is Aro here?
Ay, miss, si Aro di ay marag na disconnect kay nagbiyahe siya karon sa barko.
Aro. Okay, let me. Abeliana?
Yes, Miss.
Anything you would like to add?
So in measuring the pH of a specific product, a pH meter is used where it measures essentially the electrochemical potential between a known liquid inside the glass electrode or membrane and an unknown liquid outside. For this to work, calibration must occur by dipping it into buffers or test solutions of known pH and adjust the meter accordingly. Buffers will be discussed later in a shorter note. So here is also a YouTube link attached in the notes to see how pH meters actually work for you to be able to visualize it since we cannot currently use one. For buffer solution, it resists pH change upon the addition of an acidic or basic components. It is able to neutralize small amounts of added acid or base, thus maintaining the pH of the solution relatively stable. In our notes, you will see some well-known buffers.
Thank you. What was the importance, I hope I maka-answer naman eh, kaya ninyo eh. What was the importance of having buffers? Why is it, ganun pag we talk about pH, we're also talking about buffers. How does it affect your pharmaceutical products? Anyone from the group? Na-mention naman nga, it receives pH. So, does it help the pH for the pharmaceutical products? Ano sa man nga ang purpose? So, kaya ang importance? Anyone? Ginita or Nisandre? You'd like to try? You have here in your notes importance of measuring pH of pharmaceutical product. Yeah, let's use this. Sige, Ginita.
Yes, miss. So, pwede niyo i-repeat ang question, miss?
Sige, Katora, the importance of measuring your pH na lang for your pharmaceutical products.
It is quite significant for us to measure the pH of our pharmaceutical products since pH is a critical factor for all those medications prepared as aqueous liquid forms. Also because it has an impact on the solubility of the molecule, which determines the stability of the medications, the biological tolerability of the formulation, and the activity of the molecule.
Thank you. Canizares, can you tell us or summarize in your notes? You have your pH on pharmaceutical products. What's the highlight? What do you think is your should be your highlight for this notes?
It is also important. I will add to Ginita pa, miss, and then proceed to question. It is also important, miss, to control the pH of a product to minimize drug degradation, to improve patient comfort and compliance, and or to to improve delivery. It was also to be noted that higher pH values of pharmaceutical liquids are often required to make drug more soluble or to maintain good stability and adequate shelf life. And that especially that in pharmacy practice, pH is a critical variable and a basic understanding of its principles and measurement is important. It is vitally important to understand pH and its influence on drug solubility, stability, and absorption. Its influences are indicated in our notes, miss, the last page, the third one. And then for pharmaceutical industry, we will add to that also, it may seem trivial, but the conductivity and pH of certain materials and ingredients determines how a drug formulation or specific ingredients within a formulation functions within a system. That makes it important to understand the acidity or alkalinity of that material and the system itself. And to summarize, pH has great effects on pharmaceutical products. As indicated here, both states of pH, whether it is acidic or basic, will affect how the drug will decompose. Stability also will depend on the pH as many drugs are stable between pH 4 and 8, and also when it comes to solubility, as weakly acidic and basic drugs show good solubilizing properties, and they are ionized and the composition is at par in speed. So thus, we can see that pH is significant to be able to produce pharmaceutical products of great quality and ensure patient health outcome. Thank you.
Okay, thank you. Very good. As you've mentioned earlier, pH, no, if can pH should when we do or test for our products, we use pH meters. Okay, pH meters. Actually, you have some illustrations, no, sa inyong module 10, and these pH meters will also be in your laboratory last 9 or 10. So for the last 8, 9, and 10, these are YouTube videos, no? And you'll be given questions based on the video. So na-output to siya ay pH meter. So you'll also be able to meet pH meters. So pH meters is using giving you numerical values. So these are now the exact pH of your sample. So you also use this one in your biochem, no? If we had some face-to-face. So pH meters, we have this in our school. So pH meters gives you numerical value. So it's different sa inyo ang mga litmus paper. Are you familiar with litmus paper? And also your pH scale paper. Okay? So kanya sila change of colors lang, di ba? And just gives you basing on the color. So di siya mao dapat ang gamiton sa mga laboratories. It has to have numbers. And that is why they use pH meters. And because it is critical, no, very good. It is a critical factor. Dapat ang imong pH meters, it should be calibrated. Okay? And I also asked, what is the connection of your buffers to your pH, to your pharmaceutical products? As mentioned, buffers resist change in pH, diba? So dapat adequate amount of your buffer side present po siya sa tuang pharmaceutical products. Okay? So if maybe when you do your internship, no, especially sa hospitals, you will find out that your dextrose or your other solutions, mga vials, naanya sila yung buffers nga nakasulat. Or even kaning mga sterile products, eye drops or ear drops, you will find out na ang yung ingredients na they buffers. Because it's a liquid and it has to enter the body, diba? So it has to have buffers to resist changes in pH once it enters the body. But then again, it's not just for solution. It could also be for your solid dosage forms and your semi-solid dosage forms. All the dosage forms, you could add your buffers because there's pH in every products. Okay? Okay, follow ra, no? Sige, so buffers resist pH. So dapat changes in pH, so dapat available siya sa imo ang product na siya present para wala kaayo changes. And very important, no, you've mentioned minimize drug degradation. Very good. because sometimes we don't know what's happening inside the product, no? There may be changes, no? Nahimo na siyang acid or ni alkaline na kaayo siya. That's why buffers are very important as well. So, si pH o si buffers, mura ni sa uyab. Dapat kuyog sila sige, no? Para wala dyan changes nga mahitabo. Because, again, it affects stability. Very good. Thank you for your output. And lastly is your viscometers. Can I have Martinez? What are viscometers? Okay pa mo? Sige lang, maniuto na lagi tayo.
Good morning. Good morning, Miss. Viscometers are instruments used to measure viscosity. We all know that viscosity cannot be measured directly. That's why viscometers are instead used in order to measure an experimental parameter that is related to viscosity in a known manner. Viscometers are highly important in pharmaceutical products in a way that measuring viscosity is a valuable part of quality control and batch consistency. It is also important to measure viscosity because not all fluids behave in the same way. Furthermore, viscometers measure the viscosity and flow properties of liquids and have a wide variety of applications, measuring these properties in different substances and materials. The viscosity of a material is also a useful indirect measure of specific properties that a pharmaceutical product has, such as its molecular weight and density, as these material properties can affect flow behavior.
Very good. Thank you. How about Sheila Cabrera? Anything you'd like to add?
There are two terms are derived how the viscosity is measured. First, it is kinematic viscosity and dynamic viscosity.
Yes.
Dynamic viscosity or absolute viscosity. The dynamic viscosity of a fluid is a measure of resistance it offers to relative shearing motions. If it measured the fluid's resistance to flow when external force is applied, that is dynamic viscosity. Dynamic viscosity, it is defined as the ratio of absolute viscosity, that density of fluids. If it measured the resistive flow of a fluid under the weight of gravity, and that is kinematic viscosity. That's how it is.
How about Sordilia? You have this one in your module, no? Kinematic and dynamic. Is Sordilia here?
Yes, miss.
Okay, anything else?
There are different types of how to measure viscosity. There are capillary viscometers, rotational viscometers, falling ball viscometers, and the falling piston viscometers. With these viscometers, we can measure viscosity in different situations since those viscometers are indicated to use in a specific ways. So, in order to accurately measure viscosity, it is also important that we have to use the right instrument for a specific product. Maramis.
Very good. So you have three types, and three types has different purposes also, no? Or convenience. So it's important that makapili ta and kung dapat appropriate po siya sa to ang product na i-test. Very good. How about Coles? Anything else? Is Coles here? I think nag-chat to siya nga. Nadugay siya sulod. Nara, si Coles?
Yes, miss.
Okay, anything else for viscometers, in importance of viscometers in pharmaceutical products?
So, in addition po, miss, measuring viscosity is important when considering process conditions for materials that need to be pumped or piped. It affects dipping and coating performance, which is particularly relevant to syrups and lotions. So, viscometer also can be used to monitor batch consistency and quality control. also used to characterize plastics.
Okay, very good. How about Sumayang?
Hello,
Anything
Miss.
else?
Mabati ko,
Yes.
Miss.
Yes, yes. Nararamdaman kita.
Um, Gathering viscosity data on a material gives manufacturers the ability to predict how the material will behave in real situations. For example, if tooth if toothpaste does not have the correct viscosity, it can either be too difficult to pump out from the tube or pump out too much. Knowing the viscosity of a material also affects how the production and transportation processes are designed.
Okay.
The ability to predict how the products are going to behave when consumers get them is very important. Therefore, testing them for viscosity is a practice used by many industries before they package the products and send them to the consumers.
Before packing. Very good, no? Very good. So, Katusha, thank you for your example, no? Your toothpaste. So, it's also very hard for to squeeze it if nasubraan na siya ka viscous, no? Or if dili kayo siya viscous lanay siya. So, I'm just checking, no? If it has a high viscosity, what happens what happens to the flow? Is it fast or slow?
Slow.
Kay taas man og viscosity. Kung mo og viscosity, fast ang iya ang flow, diba? So
Yes.
mga nga nala akong question sa exam, no? Mga basic lang kaayo kay to check, no? Kay kasi bright na kaayo mo ba? Daw ka na nag-overthink na mo questions, no, Jan?
Yay! Thank you, Miss. Moriarty. Ah, okay. Oh. Loratadine, miss? Red. Oh, orange there. Oh, okay. Suspension. That's nice. That's nice. Nice. Oh. Ophthalmic solutions. Otic. Otic. Funny. Ayaw, miss. Med or Sir Wilsley. Mm-mm. See you soon.